Hey everyone, how's it going? Pretty good? All right, so as you can see, I have 157 slides, so let's do this. Then the name of my talk is clearly Opening Keynote, which is a really great one. Now, the name of my talk is A Tale of Two Asyncs, or How Language Values Shape the Features We Build and the Journeys We Take to Design Them. So, as you heard, my name is Ashley Williams. You may know me from Twitter as AGDubs. If you follow me, I'm sorry. If you don't, do it at your own risk. So I used to be a JS developer. I kind of still am. I was on the Node.js board of directors. I worked at this little company called NPM, you may have heard of. And I started an inclusive education program called Node Together to get people from underrepresented backgrounds into Node programming. And I have represented teachers' interests at TC39, though I have not been able to do it as much as I would like. And this is primarily because I now work at a company called Mozilla. And I am not doing JavaScript there. I am working on a programming language called Rust. Has anyone heard of Rust here? All right, you're about to hear like a lot more about it. So it turns out that an open source project is a little bit like a startup, and whenever working at a startup, you wear a lot of different hats. And so as you can see, I also wear a lot of different hats. Definitely didn't leave my package management love behind. I'm working on Crates.io and Cargo, which is the package management system for Rust, among a bunch of other different things. But I haven't completely left the web behind. I've been doing a lot of work with Rust and WebAssembly. This is the logo for my project WASM-Pack. So if you're interested in that, please find me in the deep track, because I'd love to talk about it more. But I can't ever leave my education roots. And so in moving over to Rust, I started working on this project called Rust Bridge, which is another inclusive education program for getting folks who are underrepresented into Rust programming. And so just for a sense of what that looks like, that's this. And we're all doing this little crab pose because that's our unofficial mascot, Ferris, for Rust. So the TLDR here is I love teaching programming, like really, really love it. And this is kind of because I really love programming languages. And this comes from this idea that I really like to think about thinking, particularly the type of thinking that happens when people write code. Now, unlike potentially many of you, I'm not a CS grad. I went to university to study film, and then I got obsessed with film theory and started studying philosophy, and then also got really into perception science. So I left university with a dual philosophy neuroscience degree. And now I'm a programmer, yay. But yeah, so in that vein, it's going to get a little philosophical. So the goal of this talk is to explore two languages I love, Node.js and Rust. I know that Node.js is not a language, so please don't come up to me afterwards to tell me. I know it's JavaScript, but I am very much a back-end developer. And so whenever I think about JavaScript, particularly async in JavaScript, I'm thinking of Node. And so that's why I say that. But yeah, let's get philosophical. So there's this wonderful man with a mustache here named Friedrich Nietzsche, and he came up with this idea of genealogy. And so in philosophy, genealogy is a historical technique in which one questions the commonly understood emergence of various philosophical, social, programming beliefs by attempting to account for the scope, breadth, or totality of the discourse. And in general, what this really means is genealogy is trying to look beyond the discourse in question towards the conditions of its possibility, which is to say, we're not just saying like, oh, what programming languages exist out there, what techniques exist out there. Why is it that programming languages like this emerge and exist at all in the first place? And so here's another lovely gentleman, Michel Foucault. And what he says here is the point of a genealogical analysis is to show that a given system of thought was the result of contingent turns of history, not the outcome of rationally inevitable trends. And so if that's a little bit hard for you to parse, my friend on Twitter translated it. She said, "That is the nerdiest way to say shit happens I have ever seen." She's not wrong. So really what I want to say is genealogy is an investigation into those elements which we tend to feel are without history. And I really, truly believe that programming languages are deeply complex historical artifacts and agents, but we rarely think of them as such. And so today, we are going to think about them as such a little bit. So this is a philosopher named Thomas Kuhn. He wrote a book called The Structure of Scientific Revolutions, which is absolutely fantastic. But in it, he writes, scientists work from models acquired through education and literature, often without quite knowing or needing to know what characteristics have given these models the status of community paradigms. And so what's saying here is, like, we are working with a lot of beliefs in our community right now, but we rarely question where these beliefs come from and why it is that they exist in the first place. So if you Google genealogy of programming languages, because I'm doing that all the time, you'll end up seeing this paper, and basically the idea of the paper is, what is the best first programming language? And I'm not going to answer this question right now, but we'll get back to it in a second. But you probably already know in technology, if you ask what is the best, it's a trap. Right? Something that we always like to say is, no, it's not which is the best. We got to find the best tool for the job. But again, this is a really confusing question. And when I think about this question and I think about programming languages and tools, I start asking myself, well, what do programming languages want? What do they want to be the best tool for? What is it that they're trying to solve? And so there's this idea of programming paradigms. And so a programming paradigm is an approach to programming a computer based on a mathematical theory or a coherent set of principles. Each paradigm supports a set of concepts that makes it best for a certain kind of problem. So we talk about best tool for the job. We can kind of understand that programming languages are solving problems for us, and some programming languages are good at solving multiple problems, and some are good at solving just a few. So the person who came up with this idea is this amazing computer scientist named Peter Van Roy, who is clearly a very serious human being. And there's this idea of the paradigm paradox, which is incredibly difficult to say, which is, you'd think if you want to make a really great tool, maybe you should make it very good at solving a lot of problems. But it turns out that there are diminishing returns in that. So when he talks about paradigms, what he says is, more is not better or worse than less. It's just different. And he took this idea pretty far. This is a beautiful diagram that makes almost no sense that he included in his book, which talks about a whole bunch of different programming languages and the different problems that they are trying to solve, and tries to organize them based on what they're trying to solve, which is super fascinating. And we'll get back to this in a little bit. All right. So what I wanted to ask myself is, what type of tool does Node want to be? What is the goal of Node? And it turns out that this is actually pretty difficult to find. And so classically, I went back to the beginning. How many people recognize this gentleman? All right, this is Ryan Dahl, the creator of Node.js, in his original keynote at JSCamp in 2009. And when he was presenting Node, he actually did a great job of talking about the problems he wanted to solve. And so what he said fundamentally was, the way we are thinking about I/O makes things difficult. And this is because fundamentally, Node.js is focused on this idea of asynchronous programming. And so Marijn Haverbeek, who wrote Eloquent JavaScript, which is the book that taught me JavaScript, fun fact, Marijn was one of the original developers on the Rust programming language. The world is small, y'all. But in his book, he introduces asynchronous programming as the type of programming that makes it possible to express waiting for long-running actions without freezing the program during these actions. And so in his talk, Ryan uses this exact example. He says, when we talk about asynchronous programming, this is all we're asking. If we do this, what is the software doing while it queries the database? And an asynchronous programmer answers, it better be doing something, not just waiting. And I think it's kind of interesting to look back at these kind of simple foundations, because when we talk about asynchronous programming in JavaScript now, it's a lot more complicated than just this idea. So interestingly, if you jump a decade previous to Ryan introducing Node.js, we started talking about asynchronous programming with this idea of the C10K problem. Has anybody heard of this? All right, so way back in the day, there was this website called Slashdot, and if you wrote a good blog post and they put it on Slashdot, it would get so popular that so many people would try and visit your blog post that it would take down your servers. And this was happening all the time, and this was a huge problem. And so in this, they say, it's time for web servers to handle 10,000 clients simultaneously. Oh, our goals were so low back then, right? 10,000, let's do it. And then in just a decade, suddenly something like Node is appearing. So it's interesting to see how really recently we really didn't have great solutions for async. So the first solution to async was threads. Now, Ryan Dahl has very interesting opinions about this. Threaded concurrency is a leaky abstraction. It creates pains. You have memory problems. It's hard to think about. It's not a good abstraction for what's happening on your computer. And he says this because he was taking a look at comparing Nginx and Apache, which were the two solutions at the time for asynchronous computing. And so in this graph, there's quite a few things happening, but the main takeaway here is that both of these can support a ton of concurrent connections. However, if you raise the number of concurrent connections, you can at least see in this graph that there's a major problem with Apache taking up a ton of memory. Now, these are the exact figures that Ryan used in his talk. I'm not super convinced this is an amazing study, but I think it's worth noting that there's been a fundamental problem with this idea of wanting concurrency and dealing with memory problems in general as we look at asynchronous programming. So for Ryan, threads were expensive, and so threads did not seem like the appropriate solution. And so what he ended up coming up with was this idea of the reactor problem. So this is the original diagram of the reactor pattern from the paper that announced it. But you might know it better as libuv, or this thing, our lovely event loop here. And so this was Ryan's response to trying to deal with threads, which Axel will tweet it as, the Node.js system diagram is single-threaded scripting language for a multi-threaded system. Whenever I teach Node, I love saying, I know we think it's single-threaded, but under the hood, it's really multi-threaded. It's just true. But in introducing Node, Ryan was like, callbacks is just how I/O should work. Now, he's given another talk recently talking about mistakes that he felt like he made in Node, and he's gone back and said, oh, maybe it should have been promises. But fundamentally, both of these things are a non-threaded solution to dealing with asynchronous I/O. And so Ryan says, JavaScript was designed specifically to be used with an event loop. The culture of JavaScript is already geared towards evented programming. And so this is why he wanted to write Node using JavaScript. So we asked ourselves, what does Node.js want? And so Node wants to provide a purely evented, non-blocking infrastructure to script highly concurrent programs. And the thing that I love about this, and I'm not going to read all of these to you, is that Node has design goals. Or, well, it had design goals. Because it turns out if you go onto Node and you try and look up, like, what is the vision for Node as we move into the future? These goals they're either difficult to find or they might not exist. So we were talking about paradigms before. Evented programming is the primary paradigm for Node.js. So before I jump into talking about Rust, which is the next language I'd like to look at, I wanted to ask, so what type of language does JavaScript want to be? And so if you thought asking what type of tool Node.js wanted to be was hard, JavaScript was even a little bit more confusing. This is the best piece of the spec I could find that answered this question. So this says, ECMAScript syntax is relaxed to enable it to serve as an easy-to-use scripting language. So what does JavaScript want to be? It wants to be a relaxing, easy-to-use scripting language. And I'll let you sit with that as we continue to talk about programming languages. All right, so I work on Rust now, and thinking about Node, thinking about JavaScript, I also like to ask the question, what type of language does Rust want to be? So Rust describes itself as a systems programming language that runs blazingly fast, prevents seg faults, and guarantees thread safety. I don't know how much this means to you, but most people I talk to when I say this hear this. They're like, oh, good. Rust is a programming language. And that's all I know. So we can kind of go back and look at what was Rust originally designed for. So Rust was originally designed as a systems-level language for replacing C++ in Firefox. And so this kind of brings us to the idea that, we're close to the metal, and we're not sorry about it. Yeah. So in general, if you're not familiar with Rust, Rust does not have a runtime. It does not have a garbage collector. It's a compiled language. And it specifically is designed to have memory safety, so to have no segfaults. And it uses static typing. The Russ Compiler is my favorite thing. This is an illustration by a lovely person named Lee Bailey, how they see the Rust Compiler. I have a slightly different perspective. My favorite thing about the Rust Compiler is that because it's able to do a ton of static analysis on your program, it's kind of like a pair. It's like working with a mentor all the time, like a super smart mentor who knows how to read all of your code. And so it's really great writing in Rust because I'm always kind of sitting there with a buddy who's going to help me out and not make mistakes. I mean, Rust's compiler cannot prevent logic mistakes. I still make those all the time. But there's a lot of interesting programming problems that the Rust compiler can help you prevent. But in this way, I try to think of Rust as a systems programming language that's designed to empower developers of all kinds to write fast, safe code. There's lots of systems programming languages out there, but Rust intends to kind of be its own thing by having a really awesome developer experience. Unlike a lot of low-level programming languages, Rust has first-class package management. And we have our own NPM registry called crates.io. If you look at the modules graph, we have way less than NPM. You might think that's good or bad. But we do have a really awesome developer ecosystem. Now, at the beginning of this year, we decided to start these things called domain working groups in Rust, because a lot of people ask, well, what can I make in Rust? And it turns out a lot of people aren't sure. And so we decided that we wanted to focus on networking services, WebAssembly, CLI tools, and embedded devices. And this is very interesting because Rust wants to be a first-class server-side language. And this is why looking at it alongside Node.js is very interesting. So Rust has several things in flight right now towards its async story. The first kind of lowest level thing we have is a crate called Mio, which is doing the lowest level I/O for us. Then we have this idea of futures. Futures are kind of like our promises, sort of. And then finally, we've now taken futures, which was originally a library, into our standard library. And if you stick all of these things together, if you want to write async programming in Rust, you're going to be using this tool called Tokyo. Now, if I was going to explain exactly how async works in Rust, it would take way too long, and so I can't. But I did draw up this diagram. This is the best I could take what we do in Rust and kind of smush it onto what Node does. I had to make my own because, as far as I can tell, one does not exist in Rust. So this is a first-of-its-kind amazing diagram. Yeah, it's close enough. Yeah, MS Paint is great. But in the long term, if you're curious, like, what does Rust look like, and how would you write like a little echo server in it? Long term, this is the vision that we have, and we have async as well, and that stuff is all landing very soon in Rust. But again, these technical issues are fascinating, and you can talk to me about them in the deep track later. But the question that I think is more interesting here is that Rust wants to be a first-class server-side language, but should it? Like, should you write a web service with a systems-level language? That's a really interesting question, I think. And I think a lot of people don't necessarily say, I need to write a web app. I'll pick C. I mean, some people do, but most people don't. And so another way to kind of think of this is, should you write a web service with a language that was designed to write a browser? And what you might notice here is that I'm kind of eliding the fact that systems-level languages, you usually write things like operating systems. But I also am kind of on team browsers are sort of like operating systems. But yeah, should you do this? I don't know. It's a really interesting question. So because Rust was originally designed to replace C++ in Firefox, which is this project called Servo, yes, that's the real logo. Like, really, that's the real logo. So Firefox Quantum added part of Servo recently to it. If you use Quantum, that's awesome. But it was its first-of-a-kind parallelized style system called Stylo. And they went from 160K lines of C++ to 85K lines of Rust. And I could go into all of the technical details here, but I think that this graph mostly explains why we would change it. Basically, it says that over time, your program is potentially more likely to work if it's written in Rust than in C. Very scientific diagram here. But this comes from a woman named Julia Evans, who's talking about learning systems programming. And she also agreed that the reason that she really liked Rust was because it made improbable programs possible. When they were thinking about an original parallelized system for CSS in browser, they have tried to write that about 3 times in C or C++ and have failed every time. It was the features of Rust that allowed them to do that. It was not really possible before. And this is because fundamentally what Rust wants to do is empower folks to write programs in a way that they can not worry about memory safety, and they can be fearless in a sense. Yeah. So we have this question, should you write a web service with a language designed to write a browser? Like, why would I ever choose Rust to write some sort of web service instead of Node? And I'm saying yes. Yes, I think you should. All right? And this is fundamentally because I still think that there's issues with this kind of conflict between concurrency and memory. How many people here have memory problems with their web app? You are all lying. I appreciate that you're lying, though. In dealing with concurrency and things, there's still like significant memory issues. When I first gave this talk, I gave it right after Matteo Collina and David Christensen gave a talk on debugging memory issues in your Node app. And I was like, yep, this is a real thing. So in Rust, what we try and say is speed, safety, and productivity, pick 3. You know, instead of picking 2, just have all of it, cake and eat it. And we've talked a lot about kind of the speed and the safety element, but we haven't talked about productivity. And I think when we talk about asynchronous programming, this is one of the key things to talk about. So how many of you have ever felt like this when programming? Yeah, it's pretty bad. I couldn't decide which one of these GIFs to pick. They were all too good. So developer experience is a really key thing. And fundamentally, when we're trying to think of what language to pick when writing a networked service, we're going to be wanting to pick something that's going to have an awesome developer experience. But developer experience is way more complicated than you might originally think. So to kind of throw something out of midair, Douglas Adams, the author of The Hitchhiker's Guide to the Galaxy, says, "The history of every major galactic civilization tends to pass through 3 distinct and recognizable phases, those of survival, inquiry, and sophistication, otherwise known as the how, why, and where phases. For instance, the first phase is characterized by the question, how can we eat? The second by the question, why do we eat? And third by the question, where shall we have lunch?" And you're like, OK, what on earth are you talking about, Ashley? This talk has gone like 8,000 different places. I promise we'll get there. So there's an amazing mathematician who wrote about stages of learning. And so when we talk about developer experience, what we need to realize is we're not talking about a monolithic group of people. We are talking about a wide variety of different people who are also moving along tracks. So this mathematician identified 3 stages of learning. First was the pre-rigorous or survival. And what these people tend to do is they tend to be very intuitive. They kindly blindly apply formalism. There's a very complicated shower hook in the hotel that I'm staying in, and I was definitely in survival mode while trying to work through this shower thing, where I was just kind of blindly turning it and hoping the temperature or the water flow would change. The next step is rigorous, or inquiry, where you kind of are like intense about the proper application of this formalism. So inevitably, after my experience in survival, I became an intermediate shower user. And so then when my partner went to use the shower, he was like, oh my gosh, how do I use this? And I was like, just the directions. This is exactly how you use it. It's incredibly obvious. I had moved from my survival, not knowing anything at all, to being like, of course, this is the one right way to do shower heads. Now, I haven't quite gotten to this level with the showerhead yet, but there's the final level, which is the post-rigorous, or the sophistication level, where you kind of return to that original intuition that you had at your first step, where you kind of like have this deep understanding of the formalism, but you can then kind of return to like thinking about other possibilities within that idea. And so these 3 stages of learning mean that there's kind of actually 3 developer experiences that you have to kind of work on when you're trying to design a programming language. So just to be completely frank, like Rust is awesome, but Rust tends to build features for the survival and the sophistication stages. We build stuff for beginners and advanced folks, because they both kind of have this intuitive idea of how they want to work with a programming language. It might be a little bit surprising, but beginners and advanced folks are actually very similar to design for, whereas like that intermediate level is really its own kind of space. And yeah, the folks in the inquiry or the intermediate stage tend to find a lot of the Rust design very frustrating, because it's not really targeted at them. So as I said, we don't have all the answers in Rust, but we are trying our best to ask the right questions. So for us, is Rust going to be a first-level server-side language? This really comes down to the question, can Rust achieve the ergonomics and productivity required to make systems-level control viable for web development? Like, we have to get the experience right. And if we don't get that right, we're definitely going to fail. So this is a Stack Overflow survey. Take it or leave it. We've been the most loved programming language for the last 3 years. I don't know entirely how much that means. It means a lot to some people. But I'm not a huge fan of surveys. Instead, I'd like to talk about this project. So this is by a developer named Nick Fitzgerald, who works on WebAssembly with me at Mozilla. And he rewrote the source maps implementation in Rust and compiled it to WebAssembly. And it turns out that doing that makes it go really, really fast. Now again, the speed part is not the interesting part here. And so immediately after posting that he rewrote something in a language and it made it go faster, because it's the internet, someone immediately was like, well, you don't actually have to do that. And this blog post, by the way, is incredibly fascinating. And so immediately after Nick wrote his thing, he was like, oh, I'm going to write this blog post saying, you don't need Rust and WASM to make your JS faster. You can just write JS that's super fast. And if you love this thing, V8, I love V8, it turns out that V8 can make your code very fast if you write your code in a very specific way. But what happened in this blog post is that he showed so many of these very interesting hacks, but by the time he was done with the code, it was completely unreadable and definitely unmaintainable. And so Nick followed up in an incredibly nice way by saying, hey, you know, that blog post was really awesome. All those hacks are really great. But our goal here is that we want to be able to achieve these values we have of being fast and stuff without the wizardry. So here Nick says, the oxidizing article recounts my experience integrating Rust compiled to WebAssembly into the source map JavaScript library. Although the JavaScript implementation was originally authored in idiomatic JavaScript style, as we profiled and implemented speed improvements, the code became hard to read and maintain. With Rust and its zero-cost abstractions, we found that there was no trade-off between performance and clean code. And so again, this comes down to this idea of developer experience. Making JavaScript fast is possible, but sometimes it's not that fun. And it comes to this, like, OK, so how did Rust get to a place where it has a pretty awesome developer experience? And this is because Rust is run as an open source project, and we have very, very specific goals and processes about how the language becomes developed. So this is a talk by Nico Matsakis and Aaron Turan, who are both on the core team of Rust with me. And we kind of talk about this idea called, why wasn't I consulted? So this is our core team here, but there are probably around 20 teams and 150 people involved in developing Rust. So Paul Ford came up with this idea called, why wasn't I consulted? And he says, why wasn't I consulted is the fundamental question of the web. It is the rule from which other rules are derived. Humans have a fundamental need to be consulted, engaged, to exercise their knowledge, and no other medium that came before has been able to tap into that effectively. And So instead of kind of rejecting that, kind of thinking that, oh, this why wasn't I consulted is like this, kind of unfair attitude, Rust leans in. Rust says, yeah, we do want to consult, and we want to consult with everyone. So in Rust, all major decisions are preceded by an RFC. We spend all of our time writing out goals, making sure that we can catalog trade-offs and explore designs. And we seek consensus, not just on the team, but with all of the community members that participate in the design. And we have this rule called no new rationale, which is that designs need to rest on prior public debate. No going off into a room with a couple of friends, making a decision, and then merging the PR. That doesn't happen. It needs to all happen in the public. And this is kind of as opposed to this idea from the Apache Software Foundation, which still, every time I read it, I'm like, is this real? So Apache goes by this idea of lazy consensus, which means that when you are convinced that you know what the community would like to see happen, you can simply assume that you already have consensus and get on with the work. So a lot of software projects actually use this idea and don't have as radically open design processes as things like Rust have. We think that it's incredibly important to articulate the vision. So asking these questions, like what does Node want? What does JavaScript want? What does Rust want? Is really key. And we make lots of jokes in the JavaScript world about thought leadership. How many thought leaders in the room? You're also lying again. But it turns out that thought leadership is actually an incredibly important thing. And being part of open source projects is a lot less to do with coding and a lot more with inspiring the community towards a clear goal, establishing shared values, and being able to identify and explain historical themes. It turns out that maybe a lot of what you learn in a CS degree is a lot less relevant to leading a large open source project than what maybe I learned in my philosophy degree. I'm not going to cite the person who wrote this book because I don't like him, but this is a good quote, which is, every good work of software starts by scratching a developer's personal itch. And I think that this is true, but particularly with large communities and open source projects, we need to get people to itch in the same way. And so what Rust does is Rust kicks off this process called the roadmap process, where we work on setting goals for the year with the entire community. And the reason that we do this is because it makes it a lot easier for us to say no. When new features come into Rust that are not aligned with our goals for the year, we don't say no forever, but we can say no, not right now. And what this is able to do is help us shape exactly what we want Rust to be in a focused way. So not only is it easier for us to develop, but it's also easier for us to share and communicate with the rest of the group, and so that they can provide feedback on a smaller set of things. And we talked about the RFC process earlier, but we use the RFC process for our goals as well. This is all always open. All right, so you probably are saying, Ashley, like, isn't that super overwhelming? How many people are commenting on these issues? And the answer is a lot. So on average, you'll probably see numbers a little bit like these. But with asynchronous features, here's our Tokyo library. You can see that the numbers of comments are going up even higher. Now, Rust is way smaller than something like Node or JavaScript, but we're still getting this much feedback. So in talking about async await, you can already see, I don't know how many people here love the emoji reactions. We do not feel great about them. But the PR for async await notation had 258 comments. And so with this kind of radically open approach to programming language design, you can probably already start to see that there are some issues with it. So we have epic problems of scale with this. RFC threads can get 100 civil, insightful comments in around 24 hours. And that's not even accounting for all the ones that are uncivil and uninsightful. But there's a ton of information overload. And that's not just for the maintainers, it's also for the community. It can be incredibly overwhelming to say, oh my gosh, how many features are in flight? There's like, 80 RFCs I have to look at, and each of them have 200 comments. How am I supposed to keep up? And I think it's very interesting when we think about open source and getting involved. We're often always talking about, code contributions or even non-code contributions where it's like docs or teaching. But what I think open source really needs is more managers. We just actually need more people kind of steering these conversations. But this pluralism is actually really positive. The idea that not everyone shares values is completely fine, and not everyone interprets those values the same way either. But when we have more than people, we inevitably end up with a better product. And it's really the job of the product leaders to take all of the different ideas that come from the community and be able to turn them into a single coherent vision. So what's the point of me talking about all of this? I've talked about Node and JavaScript and their goals and paradigms. There is a point, though, I promise. And this is because Rust wanting to be a very good server-side language has a lot to do with Rust trying to be a popular language now. In this age, there are not being a web-first or web-ready language kind of already put your language out. You're not in the running for adoption. The web really means something right now. And the web, particularly on the server side, you have to have an async story. And that really came a lot from Node. Node was not the first, but Node made that something that had to happen. And so Rust's async story is a result of Node. We are reacting to Node in how we're working on stuff. And Node, when Node was created, also existed for a very specific reason. And it was a response to the historical and material situation it was written in. So Node's not just an amazing idea that popped into someone's head one day, and neither is Rust. These things are all responding to things that were already happening in the ecosystem and filling needs that people had. So fundamentally, Rust is at least partially our response to Node. However, I think that there are ways that Node and JavaScript can also respond to Rust. These things are not only historical artifacts, so much as they're also agents. And so I think there's a couple of things that Node and JavaScript can learn from Rust. And the first one being that Node and JavaScript have not re-articulated their goals and their audience in a really long time. And I mean, there's also ways Rust can improve on this. But as a result, I think there's an overall lack of vision. We're working very hard as we develop these languages, but too often we don't pause and ask, to what end? Or for who? Why are we making Node? Why are we making JavaScript? Who is it for? And a lack of vision causes, at best, a mismatch in expectations. This is a blog post by someone named Boats, who works on Rust. A lot of people think that explicitness is a value of Rust, but we're not actually very clear on it. And it turns out that the word explicit is very interesting and deep. So check this out if you're interested in that. But what I really want to talk about is the idea of what can happen when a lack of vision has worse implications. Does anyone know this guy? This is Bjarne Stroustrup, the creator of C++. And I think that this is a really rad photo. He recently wrote a blog post where he wrote, "Many or most people in Working Group 21 are working independently towards non-shared goals. Individually, many, or maybe even most proposals for C++ make sense. But together, content warning, they are insanity to the point of endangering the future of C++. All right, so these are strong words. What the heck is going over on in C++ land? So the name of the blog post that Bjarne wrote is called "Remember the Vasa." Anybody know about this ship? Don't worry. Don't ruin it. It's a surprise. No, it's not really a surprise. All right, so the Vasa or Wasa was a Swedish ship, one of the largest and most heavily armed warships of its time. At the beginning of its maiden voyage in August 1628, the Vasa sank after only about 1,300 meters driving distance in normal swell due to serious structural instability. So this was a ship, the Swedish government's like, we're going to have a sweet ship, and it's going to make everybody scared because it's going to be so awesome and have all the features. And then it went out for its first voyage and just the end. What happened? All right, so Bjarne is worried that C++ is like the Vasa. All right, he says, we need a reasonably coherent language that can be used by ordinary programmers whose main concern is to ship great applications on time. He switches metaphors now. We now have about 150 cooks. That's not a good way to get a tasty and balanced meal. We are on the path to something that could destroy C++. We must get off that path. And so what Bjarne is really concerned about is that we're kind of building a language and just kind of fastening pieces onto the language, the way, with the Vasa, they're like, let's put 5 more cannons here and 3 more guns here, without paying attention to the cross-cutting concerns and the actual goals of the ship. So in the Vasa's case, the goal was to have a really intimidating, awesome warship. But they clearly lost sight of that by just strapping features onto it, and in the end, it ended up being the exact opposite, a complete embarrassment. So this is just a map of where it failed. I love that this even just happened in history. It's pretty awesome. But when I think about programming languages, and Bjarne obviously shares this idea when he talks about we need a programming language for ordinary programmers, like ergonomics and productivity are the determinants by which the success of any programming language will be measured. How happy people are using that language is going to determine how much they're going to reach for it and whether or not that language will be successful. And so in order to get developer productivity and experience correct, you can't just imagine it in your head. You actually have to talk to the people using it. And so in order to get these things right, we need our users to be in the room. Russ Cox, who works on Go, says, to make Go successful, we need everyone's help, and everyone isn't here. Now, in this, he was talking about diversity and inclusivity programs for Go. But I think we can take the idea a bit further, and Go is kind of a fascinating example. It's not even about necessarily, obviously, diversity and inclusion is amazing, but getting more people involved and receiving more feedback from all types of folks is incredibly important. So we're going to return back to this idea of the first programming language. What's a good first programming language? That original paper. And the paper says the major problem that's caused by the unavailability of feature uniformity. So feature uniformity means there's one way to do a thing. So the major problem caused by the lack of one way of doing a thing in a language is that the size of the language increases, which in turn results in a longer learning curve. There's more language to learn. All right, it's going to take longer. However, there's a bit more to this than you might think. It says this leads to an increase in the language complexity in terms of the number and types of constructs. Resultantly, a language without feature uniformity usually demands that an instructor teach a subset of the language. How many people here only understand a subset of JavaScript? All right, less liars this time. All right. But the interesting thing about if an instructor teaches a subset of the language is that a programmer can use the subset to write code. But for reading others' code, comprehensive knowledge is required. So growing a language can be awesome, having lots of different ways to do things, but it starts making it very difficult to read other people's code. And so, to my conclusion here, I have a small concern. I'm a little sad that maybe JavaScript is becoming not a great first programming language. And it's not even that maybe it's not a great first programming language, but like, I'm genuinely sad that if it's true, I think that it's happened by mistake. So originally, when JavaScript was designed, it kind of was designed to be a great first programming language. It was supposed to be relaxing. It was supposed to be this easy-to-use scripting language. And as I said before, I think we haven't re-articulated the goals for JavaScript in a really long time. And just looking at the features that are currently added, we certainly aren't serving this goal anymore. When I first started giving talks around 3 years ago, I gave a talk called, "If you wish to learn ES6 from scratch, you must first invent the universe." And I said this in my talk. I said, JavaScript will be the introduction to programming concepts for an entire generation of developers. And I think that's still true, but I worry that that experience is getting worse. So what to do? I don't know. This is a really hard problem, but I'm really excited for people to solve it. I'd definitely like to see all language communities better articulate their visions. And I'd like to see more feedback, or even just requests for feedback, from a wider range of people, including people who are beginners. And to this end, I think talking with teachers is a really great way to get a lot of great beginner feedback for programming language design. So I'll agree it's not always fun. Reading 8 million comments is not always the best. It can definitely get uncomfortable. Sometimes I'm like, why does adding this feature have to take 2 years? I could just do it right now. That would be great. But it turns out long run, it's not really that great. And this is the work to be done. I think programming languages and large open source projects in general are figuring out how to reach consensus at a huge scale in the open. And this is a problem that's going to be able to affect not just programming, but a ton of other industries. I mean, I think about the politics situation in the United States. Like, open, transparent, consensus seeking is not a problem that anyone has solved yet. But open source, like right now, this is what we're trying to do. And I'm really excited about it. So I hope more folks will look into that problem and will join us. Thanks.